Hello, so we are back, and this time we have a customer job. We have a nice Lenovo Legion, Ryzen 7, and Radeon graphics. I want to show you the charger because I never seen something like that. I mean, the charger has 20 volts, 15 amps. Look how big it is. I mean, whatever is going wrong on this laptop, I'm pretty sure cannot be saved. Like a shorted MOSFET, let's say. Okay, so let's have a look. Actually, let me plug the charger. Or maybe not. No, it's not coming on. Okay, let's plug the charger. But where? Here? So we plug the charger and let's see what is happening. We don't have the charging light, no charging light. Pressing the power button. Nothing happened, it's just dead. Okay, let's open the laptop and have a look inside. Okay, so the laptop is open. Pretty nice laptop, right? Look at the heat sinks. So big. I mean, I can see fingerprints of someone work here. I can see a fuse there. You see that white thingy? That's a fuse. You think can be the fuse? Probably it is the fuse. I mean, having a minus 15 amps power supply, but the fuse never get burned by itself. No, the fuse is even good. The fuse is good. I think we have to do some space here. This is normal thermopaste or is liquid metal? Not sure about that. Okay, let's leave this on one side. Let's see, do we have any voltage on the battery? Nothing, zero. Now let's check the main power rail. And the main power rail is not shorted, which is a good thing. No, it's not shorted. That means this laptop can be repaired. Let's plug the charger. Let's plug the charger. Let's see if we have our main power rail present. We do have. Yeah, we have over 20 volts. Okay, the next step. The battery still has 0 volts. Let's check if we have our 3.3 volts power rail present. You know, I'm a bit confused because the customer told me a story on the email, and here I receive another story. I mean, are completely two different stories. Let me check, please. Okay, I found it. So on the original email, he said he tried to fit a M2 SSD, and after that, the laptop doesn't have power. But here he's saying, I mean, this is a different story. The computer has overheating previously and he doesn't know what's the problem with the laptop. You know, I hate so much this kind of, you know, you tell me one story, then you send me the laptop, you tell me another story. So what's the problem now? They try to fit a M2 drive. Where? Here? Or here? Okay, let's see what is the power button. That's the easiest way to check the 3.3 volts power supply. So the power button is somewhere here in the middle, so we don't have a chance to check the 3.3. And the keyboard is not on this side. This looks like a hard job. Okay, let's take the board out, because I'm proper confused about what is happening with this one. I mean, it's nothing short, that's a good start. Okay, so here we have the RAM memory. Let's see if the battery is taking any power. 17 volts has the battery. So we have ground and we have plus, and the battery is taking 170 milliamps. The battery is taking this power or the board? Let's take out the battery. The board is taking this power, and that's bad. That's bad. Let's try. Here is ground. Here is plus, and the board is taking 170 milliamps. So the idle, the shutdown current is 170 milliamps, which is a lot. So here must be around 10 milliamps, 20 milliamps max, and here we have 170 milliamps. 170 milliamps can be taken by the I/O chip, which is shorted, and the 3.3 volts power supply shorted to ground is taking around 170 milliamps because the output is around 100 and something milliamps. Always when I see this kind of current, like 100 and something milliamps, it has a shield here, so no one took this board out. Wow. Okay, let's get a thermal camera. Maybe we can spot something on this side of the board. But that's bad. That's bad. Because the I/O chip has to be replaced, it has to be programmed. And after you replace the I/O chip, you find actually something else, and you know the story. Let's see. So we have the thermal camera. Oh, it is taking 170 milliamps. Well, what is there? What is there hot? So look under the Wi-Fi card. And I believe it's on the other side of the board, but let's take out the Wi-Fi card. No, it's on the other side of the board. Yeah. Yeah, exactly there. So what do you think is there? Tell me, what do you think is there? It's the I/O chip. That's what is there. Okay, let's take the board out. But it's weird why this board has a seal here. Hmm? Who knows? So no one took out the board? No one tried to fix it? And I do have one more cable. Wow, wait 1 second. The IO chip is not there. The IO chip is not there. That means the 3.3 volts power supply is there. Wait. So the IO chip is here, and what is here? What is here? Probably the free. We have one of those chips. And the IO chip is shorted. Just to make sure, let's check some capacitors around the IO chip. So this is a capacitor. It has 1.3 ohms. Exactly what I told you. Exactly what I told you. IT8227. Huh? Let's test it, let's go with 3.3 and see what's going on here. I'm pretty sure it's gone, because that's the only reason why the 3.3 volts power supply is getting hot. Yeah, so that's our IO chip. And we have a bunch of capacitors, like this one, short. This one is not. This one short. This one short. You see? You want to see more? This one short. This one short. You can see? So all capacitors are shorted around the IO chip. Obviously, are not the capacitors, but you got the point. Let's come with the power supply. Let's see, what do we have here? Here we have 1.3 volts, and on the other side we have 0 point something. Okay, so here it's taking 1 amp. Wow. Yeah, what did I told you? What did I told you? So one more time. Here is ground, here is plus. So check that. What do you think is the problem? 1 amp. What do you think is the problem? So the IO chip is taking 1 amp. Okay, it is what it is. We're gonna replace the IO chip. Hopefully it's nothing else. I will order the IO chip. We're gonna program the IO chip. And we're going from there, yeah? So see you on the next one. Bye. So we are back. We are about 2 weeks later. And the chip arrived from China. That's the chip. Now, I do remember I recorded a video diagnosing this laptop. I do remember we followed the classic diagnostic method 19, 3.3, and the 3.3. If I remember, the 3.3 volts power supply was getting hot. And I remember I came with the power supply, and actually the current was taken by the IO chip. So I will not check and I will not diagnose again. This time, because it's short time, 2 weeks, I think, I will trust my judgment, and I will say, let's replace the IO chip. Now, meanwhile, I asked some few people, and they couldn't tell me if this chip has to be programmed or it will program itself, because they said it's not random, depends. Can program itself the chip or has to be programmed, pre-programmed, yeah? But first of all, let's solder the chip, because even if we have to program the chip, we will program the chip based on the keyboard connector. Yeah. So let's start. I left the laptop on one side. That's a nice heatsink. Yeah, that's the board. And the IO chip is here and it's a connector next to it. Wow, that's insane. Okay, this will be hard. And here we have the RAM memory. Here we have another connector, but the IO chip is here. Okay. Okay, that will not be that simple. Just because we have this connector next. This is fine, we can cover this. But even if we cover this, I still think it will give me some problems, but let's try it, because there's no other way how we can do it, right? Yeah, I'm gonna use some Kapton tape. Good. Good. Hopefully it will work. And we have this connector. So what do you think is fine? Yeah, should be fine. Let's go under the microscope and replace the chip. First, let's take out the chip. Okay, so that's our chip. We should get rid of the reflections. Yeah, it looks better without reflections, right? Yeah. Okay, let me grab my special tweezer, like a very large one. Yeah, this one. This one, it will do the job. Yeah, that's great. Yeah, that should be fine. Okay, let's use some flux. I will use the other flux, not the Amtech. No, the Wharton flux. Fantastic. Now hot air about max temperature for 480 degrees. The air about 30%. Let's come with the air from this side, yeah? Yeah, from this side. Okay, we need more air. 40%. And the chip is out. Yeah? All good? Yeah, all good, all good. Yeah. Each pin is fine. It just flux over, and that's fine. Okay, let's come with the new chip. The new chip is here. I can only hope it will work without programming, because otherwise it will take us a lot of time. Okay, so that's the new I/O chip. Now the challenge is, let me use a nozzle. I want to do it on one take, yeah? One take meaning, let's lower the temperature to about 40 degrees. On one take meaning, once what is the chip is on the position, we are using hot air to solder it back, yeah? Good. Good. But the hard part is to keep the chip on the position, because it will run away. It is. It is. We are that lucky. I mean, we found the position from the first try. You know what? Let me go high, 460 degrees. And I think the chip is running away, right? Yeah, it is running away. It's running away. Okay, we are not lucky. But we can be. We can be lucky. If the chip will sit like that. Huh? Do you think? Let's try it. We need more air. 50% air. And the pins are getting melted, I can see. Okay, that's perfect. Perfect. Yeah, we done it. So we soldered this chip from one take. Yeah. Now all you need to do is to retake each side. Perfect. Perfect. Now let me try from the other side. Yeah, I seen that pin. I seen it. Yeah, everything looks fine. But let's be honest, you will trust this kind of solder? Because I do trust this kind of solder. So what do I want to check? I want to check this pin. Yeah, why not? It's fine. So this pin is soldered properly. Those pins, it is soldered. Let me get rid of the reflections, please. Yeah, each pin is soldered properly in place. Perfect. Now it's time for testing. Hmm? Do you think it will work or? Hmm? Yeah, the connector is fine. RAM memory. We need a laptop. Let's see what we did. I'm curious. See if it's working or not. Yeah, like that. So it has to be like that. Now the first sign, if the IO chip is okay, is if we have the charging light. Yeah, that's a good sign. Actually, your IO chip is healthy. Yeah. Now how this is supposed to be? Here like that. Good. So here I have one cable. I don't know what is this. Oh, it's coming on the other side of the board. Okay, I understand now. And this one, yeah, that one is coming on the other side of the board. And yeah, we don't care about that. We don't care about this cable either. We don't care about the BIOS battery. We can plug the screen, you know, maybe, just maybe, we're gonna see some picture. Just maybe. Good. Yes, fine. Now let's plug the battery. Battery is plugged. Let's plug the charger. I do have the charger here. Where is the charging port? Oh, it's here on the back. Okay. Where is the charging light? We don't know. You know what? Let me put a heatsink. Because even if the laptop is coming on, it will get hot very quickly. I mean, it's working, it's working. It's not working, it's not working. Simple. We plug the fans. Good. Now let's power up the laptop. I can see some light flashing here. What does mean? Still good. That's, you know, it's a sign the laptop is alive. Maybe a sign of a dead battery or something. But I want to press the power button. And no, the laptop is not coming on. Ooh, that's bad. That's bad. Flashing light must mean something. Okay, let's check the battery voltage. Let's see the voltage. And we have 13.9 and the battery is What is the volt? 15.36. Okay, so it is a low battery. Probably is not charging. Probably is not charging. Now the voltage is going down. But the fact we have light here, that's mean our 3.3 volts our 3.3 volts power supply, it's up and running, and we can check. No, we cannot check, but maybe we can. Maybe we can on the keyboard. 2 volts. Now I should have somewhere 3 volts, right? But where? Here somewhere I should have 3 volts. I check on the screen. 3.2. You see? So the 3.3 volts power supply is up and running, and my IO chip is taking the right amount of current. Now, indeed, the laptop is not coming on, so we have to find the software and reprogram this IO chip. Looks like the chip has to be programmed. Okay, so I have some bad news. There are motherboards like this one, like the gaming one, when the keyboards need like a fast response, yeah, especially the gaming ones. And they have a keyboard management chip here. This is a IT chip, okay? So this chip is the first from the keyboard, then is the IO chip. So the keyboard is speaking with this chip, and this chip is speaking with the IO chip. The keyboard connector is here. Now the problem is we cannot program the IO chip from the keyboard connector, yeah, just because we have this chip here. So the keyboard is not speaking with the IO chip, it's speaking with this chip. So what we have to do is to, it's a hard job. Usually I will not do it, but I have no choice. Usually I will order the chip from the guy from our Discord, the Pistol Computers. But I have no choice because he doesn't have the chip, so the only way to program the chip is to solder wires. So we have to solder a bunch of wires, probably like 15, 20 wires from the programmer to the IO chip. Now, how do I know the wires? From our Discord, from that guy, obviously. But what do we have here? Here we have the EC chip pins, the Super IO chip pins here. And here we have to input this on the programmer. So the programmer, it will know each pin where it's going. So we have to solder 7 here and 7 here, 14 wires. Yeah, that's all what we have to solder. 17 wires, 14 wires, sorry. 14 wires. Okay? It will be a long job. How I will do it? Probably I will stick the programmer here. That's what I will do. Let me grab some tape. That's how I'll do it. I will stick the programmer here. I will use some tape. Then a lot of wires and a little bit of time. Yeah, like that. Okay. So now we can use wires, and here we have some bunch of wires. So I can solder the wires from here straight to the IO chip. So I'll say let's start doing it. Probably I will edit the video, I'll fast forward. Okay, so we solder all wires, like 14 wires, which is insane. I can't touch anything because probably they will get disconnected. Just to have an idea, here is pretty insane what you'll see. So those are the wires, and here from the connector. But, you know, let me get rid of the reflections. Took me like half an hour. Now, to check if it's working, now is the moment, because probably, you know, from 14 wires, one is touching the others, some shorts, some, I don't know. Let's try, let's open the program. It's important if the chip is detected. If the chip is detected, we are saved. IT. Let's select this motherboard. Send in the settings. Okay. And check connection. I have to plug the charger. And it's not working. That's insane. Check connection. It is. So you see the chip, the programmer is speaking with the chip. You see, receive the ID from the IT. Now, what we have to do is to write the software on this prick. Okay, so let me press write. Let me open. You can't see the window. You can't see this window. 1 second. EC original. And now we are writing the IT chip with the programmer. Okay, so on this point, I'm not sure what should I do. I mean, there's no way we can program this chip. So we have the software on the screen. You can see the chip is detected. Yeah, you can see receive IT ID. So the software does speak with the chip. That's mean my wires are soldered properly. And trust me, I checked the wires probably like 10 times. So it's no issue with the wires. Now if I try to program the chip, let's open the bin. I get the error straight from the erase sequence. The program is still carrying on, and it will write the chip, but actually it will not write the chip. So on the end I get an error starting from the address 00. So you can see we got an error starting from the first address. Why that happened? You know, I'm just uploading this video to understand the limitation and why the people avoid fixing a motherboard on a case you have a dead IO chip. Now, why I cannot write the chip? That's a good question, yeah? We are excluding the idea of wires not being soldered properly. The chip can be dead. Can be. You know, I asked the guy from our Discord, which is doing only this. That's all what he's doing. He's programming IO chips. And he said he ordered many times, he ordered like a batch of chips, and he found a lot of dead chips. So the chip can be faulty. Okay. The next one is the chip is on board. Yeah. So we can have like one data track. Let's say it's kept in low from the motherboard, and we cannot program that pin using that pin. That can happen. So the solution in this case is removing the chip and programming the chip on a special socket, which I don't have it. We can buy it, yeah. We can buy it. I mean, I found it. This is the only one available on eBay. It's around £220, and it's coming from From where? From Singapore. And you see with something like that, we can desolder the chip, put the chip on the socket, and we can program the chip. Let's say if the chip is good, but we don't know that. So are a lot of variables on fixing, a dead diode chip. Now the other solution, and that's the easiest way, and probably I will choose it, is to speak with this guy from our Discord and order a chip. He's charging around 20 up to 30 pounds for a chip, which is, he will program the chip himself. And I mean, it's kind of worth. Look on my case. I ordered the chip, and chip was expensive. I think I paid like 20 or 25 pounds from China. So I can even go on eBay, on his eBay, and order the chip, or I can speak with him, and pay for a chip. So I'm not sure what should I do. I mean, for the love of the content, maybe I can go ahead and buy the socket. But not sure for like a normal user if it's worth something like that. We can try, but it's more complicated. So we can try some things, but it's getting more complicated. So we can try desoldering the chip. We can try soldering the wires to only the chip, but then we need a bunch of wires, to simulate actually a working chip. We need like 3.3, we need some pins connected to ground, to plus. It's more complicated. So looks simple, and I do have customer, and when I tell them, the chip has to be replaced, it's around 150 pounds for a gaming laptop, and he was texting me back, sorry, but it's only 10 pounds to buy the chip. I know, but the level and the time you put on a job like this, it's insane. It's not even worth, even for 150, I don't think it's worth. But yeah, it is what it is. There indeed are easy jobs. We've seen before just replacing the IO chip, and the IO chip is getting programmed by itself. Simple, Or we have the other motherboards, we are soldering the chip, and we are programming the chip by the keyboard connector. Kind of easy if you have the right software, Or if you know how to extract the software from the BIOS. Then we have this kind of chips, and this you will find this on most of the gaming laptops, because those motherboards, they have a keyboard controller, and you cannot program the IO chip using the keyboard connector. So you have to use wires, or you have to use a socket to pre-program the IO chip from before. So the things are quite complicated. And that's why we have on this market, we have people which they all what they are doing. They are not fixing laptops. They all what they are doing. They are programming the IO chips. And on the other hand, we have people like me. They are just trying to get a job done, but it's hard. I don't even know what should I do. But we'll see. I just, even I didn't fix it yet. I will upload the video just to let you know the challenges for replacing a EC chip or IO chip or startup chip or whatever. So I will say thank you for watching. I guess subscribe if you like the video. And hopefully we can have a coffee tomorrow. Tomorrow is Saturday, And we'll keep you updated. Bye.